problem. So what are we asked to do? Um, we are given vector A, which is 4i plus 2j. We are given vector B, which is 3i plus 1j. And we want to find your resultant vector C of A plus B. And then we will find C pictorially using the head to tail method or the parallelogram method, whichever one works best for you. I prefer the head to tail method. I just think it's easier that way. But you do you. So then we will verify our results graphically, and then we will find the magnitude of vector C, and then we will find the angle that vector C makes with the positive x axis. So just starting out, here's vector A. Vector A goes 4 in the x direction and 2 in the y direction, or we can say I and j directions. So 4 in the I and 2 in the j. So graphically, this is what it looks like. Vector B, we are given as 3 in the I direction, 1 in the j direction. So graphically, this is what it's going to look like. Now, we want to mathematically find your resultant vector C by doing vector A plus vector B. Now, notice how I set this up. I like to write these things so it makes sense to me and I don't get confused. So when I write these, I always kind of like to stack them up. And remember, we can only do mathematical operations on like components. So x components with x components, y components with y components, or z components with z components. So you see here how I have it set up. It's kind of hard to mess it up this way. So mathematically, we can find our resultant vector C by adding the x components of vector A and vector B. And we can find the y components by adding the y components of vector A and vector B. And you see here 4 plus 3 in the I direction plus 2 plus 1 in the j direction. And we get our resultant vector C as 7i plus 3j. And now we can graph this thing and we can see what it looks like. So we see that it goes 7 in the x direction or I direction and 3 in the I direction, y direction, whichever notation. Now, the next part is use the head to tail method or the parallelogram method. Again, I prefer head to tail. So what do? We take vector A. Let's just drag this thing down here, and we leave vector A alone. We leave it as it is. We don't do anything with it. Then we take the tail of B and put it onto the head of vector A. And then when we draw our resultant vector C, we just go from where we started, where our last vector ends. And I'm sorry, I know these are kind of over top each other, but you will see that A plus B is going to give us our resultant vector C. Now, this resultant vector C graphically, this is part B, looks like this. So on a test or a quiz, this is what I would be, the format in which I would be looking for. Now, part C, we are asked to find the magnitude of vector C. And we can do that by using the Pythagorean theorem. So if you need to, go ahead and draw your triangle. We know that the x component is 7 and the y component is 3. And just using the Pythagorean theorem, we work it out with a little bit of math that the magnitude of vector C is equal to 7.62. And now part D is find the angle that C makes with the positive x-axis. Here you can see I just redrew the triangle here for reference if I need to. And we know that we can find the angle using the x and y components by using, our SOHCAHTOA, our tangent, opposite over adjacent. So doing a little bit of trig, we see that theta is equal to the inverse tangent of the y component over the x component of vector c. And then we can just look at our triangle, substitute our values back in, and put it in our calculator. Make sure we are in degrees and not radians. So we see that the resultant angle is 23.2. And so you have just seen the format in which I will ask a quiz or a test question. So get used to the representation using uh, pictures, graphs, and math, and you'll be well on your way scoring that A that you're looking for. So, as always, happy solving.